welcome to my channel, Dr. Narsimha's Eduvision. So in previous video, I have shown you how to calculate lattice parameters by using analytical method without using any software package. But this method has some limitations. So in this method, analytical method, we did not consider the XRD peak width. That is nothing but full wave half width. The width of the characteristic peak we did not consider. So it is going to play a major role in determining the nanoscale of a particle. Similarly, the intensity of the XRD characteristic peak that we did not consider in analytical method. So these are some limitations in evaluating lattice parameters by using analytical method. So there you may not be getting accurate value for lattice parameters because we did not remove the noise. We did not consider the peak width, and we did not consider the intensity of XRD characteristic peak. That's why you may not be getting the perfect information about the lattice parameters when you are calculating by using analytical method. So today I will show you a simple software package that is called as powderX. So the size of this software is around 5 MB, less than 5 MB, and there is no need of licensing, nothing, but it does not require any a key to activate the product. So by using this simple software package, you can calculate the lattice parameters, the interplanar spacing, the width of each diffraction peak, okay, and you can do even unit cell refinement also. So today I am going to show you how to evaluate the lattice parameters by using a simple software package that is powderX. So here we go. Go to Google web page, then type CCP 14. So from this website, search for powderX software. So here more number of software packages are listed. So from these we have to search for powderX software package. So here it is. So before downloading, so go to instructions. So there we have an instruction. So to get the activation key, we have to send a mail to this particular person. Then we will be receiving the activation key through mail. So after installation, we have to insert that particular activation key. So here the package is downloading powderX. So after downloading, go to disk one. There you have a setup file. So install that setup file. So select all the options as provided by the software package. Then your powderX software has been successfully installed. To create a folder in any drive. So here I have created a folder with the label powderX. So here I am going to store my XRD data files which I have obtained from the characterization technique facility. So this is nothing but the raw file of zinc oxide. So now I am going to process this raw file by using powderX software. Now I am going to open this powderX software. So this is the main window view. So from file menu, go to import data. So here different file formats are listed. So my XRD file is in RAW file format. So I'm going to select RAW file format. So search for the saved file. So I have saved this file in powderX. So here I'm going to open this one. Click on open. So this is the XRD file. I have opened this one by using the software powderX. So before moving to calculation of lattice parameter, there are a few things which you have to perform. So the first point is to remove this alpha 2 radiation. So in general, we make the use of copper radiation source, which makes the use of K alpha 1 radiation with the wavelength of 1.54056, I think, angstrom. But there may be a component which is related to K alpha 2. So we have to remove that one. So in order to remove K alpha 2 exposure, so you have to click this one, test, okay, finish. Nothing but the intensities which are related to K alpha 2, copper K alpha radiation, those are eliminated. This is the first step. And the second step you have to follow is you have to remove the background. Okay. So this is the key, subtract background. So the process of the need of removing background is it is used to remove the non-crystalline nature of the material, the intensity which is related to non-crystalline material. So that can be removed by using this option. Moreover, if you use this particular option, remove background, so that will give you more accurate fitting values, more accurate refinement values, indexing. So you have to do that one. Then the third step is smoothing. First of all, I am going to remove the background. Okay, click on show. So here, this is nothing but the background which will be removed. So the background has been removed. Then the third step is smooth of data. So the need of smoothing of data is to make the signal to noise ratio better. Okay, so to improve the signal to noise ratio, we have to smooth the raw data. Moreover, it is also going to provide the visibility of diffracted peaks. Okay, so here we are going to smooth the data. I can show. Okay, so first step is to remove the intensities which are due alpha to radiation. The second step is to remove band, and the third step is uh, to smooth the data. So first you have to do these three steps. Then the next most important step is nothing but selecting of characteristic peaks. So automatically you can select or manually you can select. So here I am going to select automatically. So go to peak. So here you are going to find a simple peak. Click on simple. So first of all, I am going to click on show. So it will show the peaks along with the characteristic peaks. So these are the peaks. You can see here there is a peak, here there is a peak. So these peaks may be corresponding to background data or unwanted data or amorphous material. So you have to select these peaks only, this peak, this peak, this peak only. So for that purpose, I am going to change these values, select ups and intensity. So I am going to change these values such that I am going to select the required peaks only. So here you can see first peak, second peak, third peak, fourth, fifth, sixth, seventh, eighth, ninth. So I have selected the required peaks of zinc characteristic peaks of zinc oxide. So now click on OK. So here while scanning the sample, so most commonly the radiation source is copper element with a wavelength K alpha 1. So that is 1.540598. So click on OK. Then it is going to ask you to show to store the information of the peaks. So here I am going to this one as one and save this file as a text file. Okay, so remember to save the file in the folder which we have selected earlier. So here the folder is powderX, in which I am going to save this file. The name is one. So this is the first file. So click on save. So it will display the 2 theta positions and the corresponding interplanar spacing values and the height nothing but the intensity of the corresponding XRD peaks and the area covered by these peaks and the width of uh, the characteristic peaks. So this is the information you don't get in analytical method. So there we can calculate only A and B, nothing but lattice parameters. But along with the lattice parameters, it is important to get the values such as the position, interplanar spacings, and the width of peaks, because the width of characteristic peak is going to give the nanoscale that can be calculated by using Debye-Scherer's method. So I am going to save this file. So save as. So already I have selected the file 1. So here I am going to save this one as 2 and file type is text. Okay, closing. Then go to indexing. So here indexing, click on DHKL. So name of the sample here. So my sample is ZNO. So I am going to type ZNO, hexagonal structure here, or you can select anyone depending on your sample. So here zinc oxide is hexagonal. What's the crystal structure? That's why I'm going to select only hexagonal. So in case of hexagonal crystal structure, the lattice parameters A and B both are equal, and C is not equal to A and B. While the crystal angles are alpha beta are 90 and gamma equal to 120 degrees. So you have to select these values A and B. So for this purpose, I am going to a standard database that is called as crystallography open database, or you can access any standard database like ICDD PDF database. But the crystallography database is a free database, so there is no need of purchasing the data. So it is freely available. You can download the database from crystallography open database. So here I am going to make the use of this particular database. So this is nothing but the data entry card number 96,900,4182 and the corresponding lattice parameters of zinc oxide according to this database. So small a value 3 point, okay, so this is nothing but 3.2533. So here I am inserting, okay, then moving to C value. So from the database, the C value is 5.2073 angstrom. Okay. Then first of all, I am going to calculate. So on pressing this calculate button, so here you can see all the peaks are identified. Okay, here you can see the corresponding HKL values are given. Nothing but all the peaks within the diffraction pattern are identified by the sample by the software. So again, I'm going to save this one with the name 3 and file type is text. Okay, closing. Then I'm going to click on this peak match button. So here you have to adjust the 2 theta error value. This may be due to instrumentation while instrumentation setting while scanning of the sample. So here you can see only one peak is identified. Therefore, I am going to change this value. For example, if it is 0.08, so peak match. So 1, 2, 3, 4 peaks are identified from 8 characteristic peaks. So again, I am going to change this value to 0.1. So click on, okay, one more peak is left. So I am going to take the value 0.12. Again, so you can see all the peaks are identified 1, 2, 3, 4, 5, 6, 7, 8, 9. So all the peaks are identified. So I'm going to save this one with the file name 4 and format is text format. So close this one. Then go to refinement. So we have given standard database values. Okay, and when you click on this refine cell, it is going to give you uh, the actual values of the sample. So the sample which you have fabricated in your lab, so the samples lattice parameters will be given here. So I'm going to click on refine cell. So this is the file. So here you can see 3.24925. Okay, my sample is zinc oxide and the corresponding AB values are 3.24925. But according to standard database, it is 3.2533. Okay, according to standard database, it is 3.2533. But what I have got is 3.249. So it is very close to the standard database. Similarly, you can see the C value, lattice parameter C, it is 5.2049. So here we have given 5.20. It was 5.2073 according to standard database, but here I have got 5.2049. So it is very close. So the evaluated lattice parameters of my sample are well matching with the standard database. Okay, so this is the value unit cell volume 47.58. So you can calculate C by A ratio. So this is C value and this is A value. If you calculate the C by A ratio, that will be in the range of 1.6, because C by A ratio for hexagonal crystal structure, that should be in the range of 1.6. So for my sample also, if I calculate C by A value, so that will be in the range of 1.6, means my sample is hexagonal structure and the obtained lattice parameters are well matching with the standard database crystallography open database. So again I am going to save this file with the name file, and text file is, type of file is text file, then save. Then I am going to close the total entire software. So directly go to the file labeled with the last name, that is file. So this is nothing but the final output. So here you can see these are nothing but the lattice parameters are according to standard database. So after doing nearly 10 iterations, the total final output is nothing but this one. So this is our result. Lattice parameters ABC along with the unit cell volume. Okay.